Go ahead, Floyd.
Alrighty, and you can change the slide, Ray. So my name is Floyd Del Muro. I'm the Business Development Manager for ARCAD Software. Welcome again. Today's topic is DevOps for IBM I using ARCAD, GitHub, JIRA, and Jenkins. The short title should be Continuous Integration, Continuous Workflow. I am joined today by Ray Bernardi, Senior Technical Consultant, my normal partner in crime here at ARCAD Software. Why don't you say hello and tell us about yourself, Ray?
Hi, everyone. I'm Ray. I'm from ARCAD. I've been with ARCAD now going on, I guess, 12 years or maybe 11. I'm not sure if I can still count. Been in the industry for about 30 years. Been working with application lifecycle management and so on and source control for all those years. So hopefully I will be talking about things that will be pertinent to you today. Go ahead, Floyd.
Thank you, Ray. However, today we are honored to be joined by Vitor Monteiro. He is a solutions engineer at GitHub. If you have any questions about Git or GitHub, today is your lucky day. So say hello, Vitor, and tell us about yourself.
Hi, hello everyone. Thanks for joining today. My name is Vitor. I'm an architect solutions engineer at GitHub. I've been at GitHub close to 3 years now. And before I worked in investment banking, and in fact, I've learned how to use Git and GitHub not in a cool startup or an open source project, but in the thick of investment banking back in 2010. So a lot of my experience with Git and GitHub is in the enterprise and not in the open source community, contrary to a lot of my colleagues. So I believe I can give you a perspective today of how these products and tools do work at scale in enterprises. Thank you.
Alrighty, thank you. So the game plan for today is I'll have a few more slides, and then I'm going to hand things over to Vitor. He's going to cover Git and GitHub. Shortly after that, Ray and Vitor will take you through a day in the life of the developer, a complete kind of change cycle, and explain the integration and innovation behind today's topic. Next, Ray. Just some quick housekeeping. ARCAD Group. We've been in business 25 years. We have 3 wholly owned subsidiaries. ARCAD Software, which is our IBM I-centric division, if you will. World leader in ALM, Application Lifecycle Management and Modernization. We also have Drops Software, which is a system agnostic release management solution. It was just added to the Gartner Magic Quadrant. If you'd like to know more about that, please reach out to us. And Dot Software, which is also a system agnostic, data-oriented testing solution around data testing and anonymization. So you can see innovation really continues here at the ARCAD Group as we continue to grow both in size and our footprint in the marketplace. Next, Ray. We are a global software company with multiple offices and clients around the world. IBM does resell ARCAD technology, and we are by far the leading business partner in the IBM I space around modernization and DevOps. So you can see the breadth of our reach right there in that little map graphic. Next, Ray. There are 3 main areas of concentration or expertise, both in terms of tooling and services that we offer here at ARCAD. DevOps, today's topic, but we're also very prevalent in the modernization space, and again, data masking, anonymization. So if you'd like to have a free strategy consultation, don't hesitate to give us a call either after this event or subsequently down the line. So enough of that. We'll go to the next slide, Ray, and we're going to start to talk a little bit about culture. So in my travels, and especially over the last 5 or 7 years, I've been seeing some significant changes in the IBM I landscape. You know, a comment that I often hear in our platform is that we're kind of like dinosaurs. I hear that from new young management that might be coming in. I hear it definitely from the business side as we talk about modernization. Young developers, if they see an SEU screen, even existing IBM I keepers of the source and the system. But as many at IBM, people like Tim Rowe and Allison Butterow will tell you, nothing is actually further from the truth. That's really going to be a discussion for another day. There is, however, a culture in our world that if it's not broke, you don't want to fix it. This kind of unwillingness or inability to incorporate change that is really deeply embedded in our workspace, in our environments, in our culture, and it creates a gap that kind of exists today. I don't have to say much, but I could say RDI, for instance. If you're still using SEU, it's been deprecated for more than 10 years. And I know many of us are frustrated by the lack of advancement and the need to still talk about that. So I speak and participate at many events, and the topic of change and onboarding new talent is constant and consistent today. And this slide is really, in simple terms, meant to represent our current state of ignoring this culture. As we push these hybrid development environments due to mobile and web initiatives, this DevOps gap can widen. And if we continue to ignore both upstream and downstream in this value pipeline flow, I think you're just going to see that that ship is just going to keep sailing further away. So today our hope is you will see that we can close that gap with the help of our good friends here at GitHub. Next slide. You know, part of the issue has been the status quo. We're not really providing the workspace and challenges where we reward that kind of innovation. It's all about keeping the lights on. LBLs, little blinking lights, as Larry Bullheis would say, one of the leading admins in our space. Well, the open source world has not been really operating that way. Agile and lean methodologies have kind of broken that glass ceiling and the dogmas of yesterday. It really is kind of a brave new world in development, and we hope to demonstrate that today. Innovation, modern tooling and processes will also help you attract that new talent and hopefully teach some of these old dogs some new tricks. So why don't we jump to the next slide, Ray? So here's a graphic that shows how ARCAD has changed its paradigm for source control, because we were a traditional change management company, but now we offer plugins, and we offer these plugins to other source control management tools, SCMs, such tools as IBM Rational Team Concert or Microsoft Team Foundation Server. These are the commercial offerings from the big boys on the block. But the current winner, the one that is kind of gaining the most traction today, and I'm sure you've heard of it, is Git. You know, ARCAD back in 2013, we really started to endorse this idea of supporting and integrating with other open SCM tools. So in this model, we kind of hand source control over to a single repository, regardless of language, such as Git. In our example today, Git and GitHub. And the truth is that the pessimistic source control checkout lock model that has been used in the past is really slightly outdated today in our bimodal enterprise. It's not true versioning. It's like Git, which is an optimistic source control tool, and that methodology will continue to tax and fail more often in a hybrid environment. So the key thing there is that ARCAD still kind of sits in the middle of all this. We collect what's been done. We use the ARCAD repository to figure out how to handle these IBM artifacts correctly when you are making changes. It does it automatically and kind of seamlessly in the background. And that's really going to be important as you move forward. So we're going to learn more about this as we get deeper into this presentation. We're going to learn about the platform responsive features and functions that will integrate for builds, test, and multi-platform deployment that ARCAD provides. And at the end, how important that is to be able to deploy to all servers and orchestrate that from even a single model, modern console such as our drop software for release management. Next slide. So today the plan is to show how IBM I applications, thanks to ARCAD, has arrived to the 21st century. Vitor and Ray are going to show you how we blend these formerly disparate worlds of open source and I by sharing a mixed stack of tooling and processes centered today around an IBM I change. We're not going to build the specific business case for you here, but if you'd like to have that discussion, we'd be glad to do that. Today's presentation and demo will use a combination of ARCAD-centric features and functions along with tools from the distributed world. As I mentioned, we're going to integrate with JIRA, GitHub, Jenkins in today's workshop. If you have other players in your toolbox, such as Docker and some things like that, we'll be glad to talk about how they can be used as an alternative path as well. There is no other ISV doing this. There are plenty that will probably try to follow, but there really is nobody else that has this integration to the level that you're going to see that has detached or decoupled its functionality to allow for a single SCM, single repository model. Next slide. So together with GitHub, we're bringing RPG and COBOL to a collaborative platform, to a social development environment. We will continue to provide the platform responsive features and functions necessary. The rebuilds, for instance, the compilations that are required in our world, and we'll continue to bring value to the flow. GitHub at the same time will bring its unique features and talents to the workflow, accepted and proven in the open source community. And I think together you're going to see a powerful solution today that hopefully will change your minds and compel you to start taking some action now as that chasm again continues to widen. Next slide. So we're going to talk a little bit about the players today. JIRA. JIRA was developed by an Australian company, Atlassian. It is used for bug tracking, issue tracking, and project management. One of the cute tidbits that Ray had discovered is that it's actually from a Japanese word, Gojira, which actually means Godzilla in Japanese, and that's kind of how the company got its name. Again, it's used to measure and track your value, hypothesis, your change, your fix, or new feature to your software. It's really important that you start to measure things. Today's talk is about continuous integration, but you need an agile way to provide that methodology of issue tracking as you go through your DevOps value stream. One of the ways they do that is they start to use boards to display the information. They have a Scrum board. Today we're going to be using a Kanban board. It's a workflow visualization tool that enables you to optimize the value flow of your work. You can communicate status, progress, and issues, and you'll see that that's going to be updated kind of seamlessly in the process today. The next player besides JIRA is Jenkins. It's an open source automation server written in Java. It is open source. It can trigger builds by various means, for example, by commit by a version control system such as GitHub, and today's topic will show you a little of that. It's by far the most accepted build engine out there, kind of the standard. And so far you could hear that we've got ARCAD, we've got JIRA and Jenkins, and at this time I'd like to hand things over to Vitor, and Vitor is going to talk about Git and GitHub.
Hello again. So one of the most important things to kind of kick off with is the difference between Git and GitHub. Because of the popularity of GitHub, a lot of people assume they are one and the same thing, which is not true aside from the name, which is partially the same, and how GitHub leverages Git. So Git in itself is a version control system. Git falls in the same bucket as something as SVN, RTC, CSM, CVS, MKS, or the very first of them all, which dates back to the early 70s. So basically, a version control system is only responsible for saving your changes, whatever those are, and allowing you to catalog that into a series of versions that you can go back to. Okay, that's version control. And Git is an excellent version control. It's a distributed version control sorry, I think we're one slide ahead. So there's one slide about Git before. Is that it? So Linus Torvald, the creator of Linux, invented Git to manage the Unix, the Unix code base. And he did so because he didn't think the other version control systems at the time in 2005 were good value for the challenges. One of the biggest differences of Git versus something like SVN is its decentralized nature, meaning that today, if you have an SVN repo or another centralized version control system, and you want to do a basic operation like, I want to compare the file I have in my workspace with a file from the previous version, that's just not possible without a network operation. So every time you need to access anything other than your current workspace, you'll have to go to the central repository. Which means, for example, any kind of offline work that you wanted to do. For example, imagine that I'm on a train going to work, for example, and I simply want to commit because I finished my changes and I want to continue doing work on another branch. I can't. I need a server. If I want to quickly branch out and I'm working on a place without internet, but in fact I need to branch out my piece of work, I can't because I need network. So when you clone a repository in Git, you get the whole repository. You only need network access to push changes to the upstream repository or to fetch changes. And since we all work in offices, that might seem, oh, that's like, in my company, I'm always at my desk, so why would I need that? So that allows you to do many more things. For example, changing branch in Git is a sub-second operation. How long is in your version control systems? I bet it's not as fast because you still need the network connection and you need to copy the whole folder structure to the new structure. Creating a branch is a sub-second operation in Git. It's just a pointer. So this allowed us to move more to a place where developers stopped complaining about branching because branching was so painless and quick that branching became a thing that you did much more often than before. Because Git obviously didn't invent branches or anything like that. So Git is much more advanced, it's newer, it's decentralized. There's a lot of things you can do because you could have a cascading of decentralized repositories all inheriting one from the other, and there's a lot of interesting contribution patterns, especially used by Linus on Git. But moving now to GitHub, Git didn't solve any of the collaboration problems. Regardless of how faster you were coding and how faster you were versioning and changing from version and changing work stream to work on a different version, the way you collaborate with others is still the same. How do you explain that a product like GitHub that came out in 2008 went from 0 users to 20 million users in less than 10 years? There was clearly here a problem, a solution that no one had seen before, and that's the way we collaborate around code. We all write this code and we send it to a central server, and that could be Git, right? But how do you reach to that code? You need a Git client, you need an IDE, you need RTI, you need Eclipse. But how do you see this code really? If you're not an expert and you're not touching the code with an IDE, how do you see it? So GitHub, I think, solved this problem in two different ways. One of them is that you can just address code and repositories and reviews just by reaching it with the hyperlink. So I can give you a link to all my code in github.com, and you can just navigate to it. So before GitHub, if you're doing a code review among 2 people and you're not sitting in the same office, how do you send code to other people? You send them on an email, but then notice that email is a private communication because 2 people, and everyone that could take advantage of that conversation is not taking part. In 2 weeks' time, someone might ask the same question, and you're now CCing another person, and you're again having this private conversation around code that no one can see within your closer team. So GitHub basically addressed how people collaborate around code. It made code transparent. For example, today, if I want to send a piece of code to my manager, I just send him a link to the lines of code that I'm talking about. And my manager can open that link and see the code, but see all the files around that code. He doesn't even need to know Git to see what's happening. If I send him a pull request, which is something we'll learn about later, my manager can see the discussion we're having around the code, and he can see what is pertinent in terms of unblocking the situation. A developer is thinking this is not performant enough. Another developer is saying it is. All of that becomes transparent. And this is really how GitHub exploded, because everyone was doing code reviews in spreadsheets, in emails, desk to desk. And as the workforce becomes distributed, there's no place for this type of communication, because I have a super important discussion today with some of you on an email thread. I leave the company, the other people leave the company, and that discussion about code that will be in production in 10 years' time is gone forever. Right? No one is going to scour email exchanges of previous employees. With GitHub, all that information stays, and it's just part of an ongoing conversation. And as you can see in the slide, there's a ton of features which it's impossible to drill down into. We'll see some in the demo. But another one is just how, after using GitHub for a while, how you take searching code for granted. Like having a single searchable code repository like Git for the whole company is truly amazing. For example, when I've been a client-side developer for most of my life, and then I migrated to a full-stack developer where I did Java. A lot of the ways in the investment bank where I worked to find solutions to the code I needed to write was literally to copy paste the name of the library that I was trying to use and I couldn't for some reason, put it on the GitHub search global box, and it would find everyone within my company that was using that library. Because GitHub is a social network, I could then mention those people in pull requests, like you'll see in a minute, and ask, hey, Steve, we never met, you work in somewhere else in the world, but I've seen that you write a lot of Java and you've used this library. Does this look okay to you? And all of that continuously gets logged. The ability of search is that the other massive benefit of search is that if you do not have a capacity to search code and search what has been done before, how it has been done before, you're blocking reusability to an extreme. Okay, so today you need a building block to build a new website. What do? You go to Google and search, and you probably find a building block in GitHub. It's not your program, but it will allow you to get 50% way there. Why not doing that within your company? How much code are you rewriting every year? I've asked the CIO of one of the largest banks in the world during a talk I was giving and say, how often do you think you rewrite the CSS components of your brand? Just literally probably 10 or 20 lines of CSS. How many times a year do you think that happens within the bank? And without blinking, he said about 100. So it's normal for us to think that rewriting the same code 100 times a year is not an issue, because that's how the world has been working. But with GitHub in place, you can just search for code that you can reuse within your company, private intellectual property, and support that code and help maintain that code so other people can use it. Next slide. So we'll see this in the demo, so I won't spend much time in here. But basically, with the benefits of Git branching and the automation checks that GitHub brings into the pull request, a pull request, it becomes an issue with code, meaning that it's a conversation that I've attached code with, and I'm asking Ray or I'm asking Floyd, saying, hey, do you think this is good quality for me to bring this to a release branch or to a main branch? Okay, and GitHub, during that process, fires off a bunch of notifications to other services like Jenkins, automatic code review, static analysis, and reports results to tell me the quality of my code. More than that, I will have colleagues of mine coming and providing me a code review. Studies show that fixing, in traditional development, fixing a bug in development is costs one unit of whatever the unit is in your company. Fixing a bug in production is 27 times that price. And this is in traditional, let's say, Java or Node or JavaScript web dev companies. I know that iServer has much more controlled deployment processes for environments. So can you imagine how much time do you save if you find a bug during this pull request process versus creating a fix and a deployment process for something already in production? It's probably much more than 27, right? So a lot of the times people ask me, oh, but now a code review is going to slow me down for like 1 hour or 2 hours, or how long it takes for the other person to do an effective code review. But if you think that if something is wrong with that pull request, you'll probably spend a total of 100 hours through the whole company to get a one-line change back into production. So there is real value here, and we'll see that during the demo. Next. Okay, and such as a closer for this part, it's important to note that GitHub.com has become popular, being the open source home for the world. I think we host about 92% of all open source projects in the world. It's 20 million users. It's probably the biggest library in the world. And that you can use for free as long as what you create there is not private. You might want to make it private, and we have private plans for that. In fact, we have a business product for companies that want to be using GitHub as a software as a service. And together with SAML, you can authenticate to github.com with your SAML provider. Most enterprises, especially in finances, use what we call GitHub Enterprise, which is a version of GitHub that runs within your own servers and infrastructure. So this is a complete private instance of GitHub that we as a company do not even have access to. Okay, and there's a small portion of customers that do buy GitHub Enterprise, but through a service provider that manages the software on their behalf. So we have all these options out there. If you think you could benefit from one of them, feel free to talk to us afterwards. Right?
Okay. Thank you, Vitor. If you've been listening, I think what you're starting to discover here is that we're starting to define a new tool set for you guys. And really, what this tool set is a tool set that should be common for all of your different teams. And this is Ray, by the way. And really, what this new tool set means is it should be less training for your new and your existing staff, less cost, less maintenance. This is a fully integrated tool set. There's no bottlenecks built into this. Your teams should be able to spend their time writing and and doing code rather than stitching tools together. And that's what this is all about. Now, so where does ARCAD fall into this picture? That's really what I'm here to show. Well, what ARCAD does is it's addressing the gaps around the IBMI in the areas of development, code review, testing, and deployment. You saw that we have JIRA. We're using that for planning and task tracking. What you're going to see today are some other tools coming from ARCAD. ARCAD Observer, which allows a developer to do cross-reference, complete analysis of a component, how it's being affected on the IBMI, right down to a field level and a code line level. And you can do that right out of RDI. We'll mention ARCAD Verifier. That's our testing tool. That's a fully automated part of our solution. And really, if you're doing DevOps, you're looking for automation. That's what this is all about. You heard us mention drops earlier. That's to deploy changes. We can do that to any server. Now, in the time we have today, we can't possibly show you all of these solutions, but we're going to show you what we hope is a workflow that you'll understand and start to adopt. Hopefully, we're looking for continuous integration here. That's what we're trying to do. We're trying to get everybody to a point where everything is automated. We're doing continuous integration, continuous deployment, and ARCAD's there to do the full dependency management, help out on the system I side. That's where we fit in. So again, a real modern tool set. And it's designed for developing modern software. It's the DevOps cycle. We want to fully integrate that into your company. Every time a problem occurs, we want that to start with the end user and come all the way through deployment within the same software. One vendor to call, basically. So we help with all of that. We automate the build. We automate the testing. We can handle the deployment. We can put it out on every server. And we're using the tools that the community knows and loves, things like Git and GitHub. You've heard about those today. So just another couple of slides for me to give you an idea of what I'm going to show you, and I'm going to get you right into the software. Really what we're here today is to take a look at the solution, continuous integration using JIRA, with ARCAD handling the IBMI builds, with GitHub and Git as the repository. This is kind of a typical architecture. Let me kind of go over this just a little bit. So you see that we're using JIRA and we're using GitHub here. We've got those up in the cloud. That's the way we did this today, okay? JIRA, we set that up with a project, and we enrolled a team into it and so on. So there's a little bit of configuration work to do in JIRA, nothing heavy, nothing scary. We added some workflow triggers so that operations in GitHub would perform actions within JIRA. That's what you're seeing here. So in other words, if you perform a push or a pull or something like that, something's going to happen within JIRA. The task will update itself, okay? So that's a status update, fully automatic. Our GitHub repository, we loaded that with IBM iSource. And the way we did that was here, we were using a Windows workstation. We were in RDI. We were using iProjects. We built the iProject and we pushed it up to our repository on GitHub. We have Jenkins installed in this picture as well. And Jenkins, we installed that on a Windows server. And into Jenkins, we also put the ARCAD Builder plugins, okay? Remember, these are the things that do the smart build on the IBMI side. Dependency handling, automatic dependency handling. Without Builder, if you change a physical file, from Git, you'll get a physical file. With Builder, if you change a physical file, we'll give you the physical file, all of its dependencies recompiled, everything done for you. Now, on the IBMI over here, we've got ARCAD Server installed, obviously. That's where the repository is that Builder uses. So Builder's actually in communication with the I. It's looking at our repository, the same repository that developers are using for analysis and so on. So this thing is following you all the time. Whenever a build gets triggered, we're going to use it regardless of how that build gets triggered. And that's how we're doing smart dependency analysis. And finally, down here, that developer's workstation that you're seeing, what you're going to see on there is RDI. You're going to see eGit plugged into RDI. The ARCAD plugins are installed and so on. And those are really kind of the moving pieces of the demonstration today. So let me go ahead and show you how this works. Give me 1 second here while I switch some screens up. Okay. Come on. Okay. There we go. I should be able to show you that. And there we go. So We're going to start here with JIRA, and you should be able to see this okay now. We're going to start in JIRA, and really what I'm talking about here first is a Kanban board. And what a Kanban board is that to-do list type of thing. It's pretty active. You can see a task over here, sitting here, waiting to go. You can see, other areas that we've set up, and you design all of this. So these categories and so on are up to you. Over here on the right, you can see a lot of information about the task, and you even have hooks into other things like Git and so on. You could literally create a task here. You could create a branch here. You can see that. So you can perform a lot of the operations from many of these different tools. They're all fully integrated with each other. For today, though, we're just going to have the task out there. Now, I've got a task out there to go ahead and make a change to a file. Okay, that's what we're really going to be doing today. And typically, the first thing that you need to do when you're making a change to a file is start with some application analysis. So what you're seeing right here is called Observer, okay? And this is plugged into RDI, and what it's doing is it's looking at the repository that we have for ARCAD out there on the System I. That's where we store it. So here in this lower panel, what you're seeing are all the components that make up a business application. And then what we can do is we can take any one of those components and we can start to drill down into it. So we've got a search feature down here. We found a file. We'll take that file. We'll ask for how it's used throughout the system. And what it does is it presents us with this panel right here. So we can see that there is a logical attached to this physical. The logical, these components are using that logical. So this is all our repository on the IBM I. This is Observer looking at that repository. And this is the same repository that will be used when we do the dependency analysis in Builder when we kick off the build. This thing has a lot of information in it. Stuff like calling chains. You can see where a program comes from, what it calls. You can see the parameters passed between programs. You can build diagrams with this. So Observer is part of this offering. It is a way to look at the change, analyze the change. The repository that it's looking at comes into play again later, Builder. Okay, making a change, fairly easy operation. Basically, what you're going to see here in a second is RDI. Okay, and where we are right now is we're switching over to iProjects. So this is iProjects. You should be familiar with that. If you're not, get familiar with it. You'll be using it. So you create an iProject, and what you do is you grab all the source. You pull it down into an iProject. You push it up to the repository. Those are the initial steps. Now, in this case, what you're seeing basically is team. We'll come down here to switch to and new branch. That's typically the beginning of any change. You typically don't work on the main branch. You typically would create a branch, work on that branch, and then merge that branch back into the main when you're done. So this is typically the first step. And notice that we're doing this right out of iProjects, right in RDI. We're creating a new branch. And what we'll do here is after we create this branch, I'll bring up eGit. Okay. And eGit is a free plugin. You can go out and download this if you would like to. And what eGit is going to do is it's going to show you, where that branch lives and so on. Actually, I'll show you in just a few minutes. You can see the branch down here. We've created it and so on. But we'll pick up on it again in just a few minutes. What we're doing now is we're going to go ahead and find the file we want to change. We'll make a change to that file. And notice, again, no checkout. Floyd talked about this. Okay, you won't ever see a checkout on this type of development. So we're going to go ahead and make the change that we need to make. And when we're done making that change, we just save the change. There's the save right there. And there's a real special panel right here. It's called it's monitoring what's happening within the Git repository. And basically what it's seeing here is any changes that you're making. There's really three states of a file in Git. Okay, it's modified, it's staged, or it's committed. So right now, this file is modified. We've changed it. Okay, and what we're doing now is we're doing the step called staging it. It's not really going anywhere. It's not moving anywhere. You're basically flagging it to be part of the next commit. That's what staging does. And as Vitor said earlier, all of this is happening locally. I'm not connected to a network. Even the source that I'm working on is local at this point in time. So over here, a commit message. What is commit doing? Commit is making it part of my local repository, basically. Okay, you're saying I want this change. So that's what the commit does. So we're going to give it an IBM I-20 designator here. That's just our task designation. So we basically follow that with our tasks. We keep that in the commit message for ease of use later. We'll do the commit. And now this is eGit that you're looking at right now, okay? And if you look up here, you're seeing a local area right here. And here you see branch 20 that we have been working on, okay? So that's the branch that we just created right here. And if we look at the remote side of this, all right, note that there is no branch 20 yet, okay? There's nothing out there on the remote server yet. So I have a repository. Yes, I have a full repository on my PC. There is also a full repository out there on a remote server. That's where I got my repository from. So this all comes back to that idea of a distributed version control system. We all have a full repository. All my operations are local until I push. And when I push, I'm making the operation happen in the remote server. Now in this case, I'm pushing a branch. Okay? So I'm not merging back here. I'm just making my changes on the branch, and then I push the branch up to the remote. And that's what's happening right now. Here's the push confirmation. There's the push. When all is said and done, what we end up with is that branch on the remote server. Okay, so there's branch 20 now out there on the remote server. So now my code is available to anybody else who wants to do a pull on this repository and get their workspace loaded with all the code that's out there. Okay, it's not back in the main yet, but it's out there. So the next step would be, I've done my changes. I want my changes to be looked at. I want my changes to be made part of the code. So I'm still on a branch. It's not going to happen out here. So what I have to do is ask for a pull request. Before we do that, though, let's take a look at JIRA, and we'll see what's happened within JIRA. If you recall correctly, we had some triggers established. So you can see here that the task has jumped over to in progress all by itself. Okay. In addition, it's getting information right out of Git. So you can see that there's a branch. There's been a commit. You can literally drill down into the commits. You can see exactly what was committed. You can see exactly what was changed in each commit, right down to the line of code, right out of JIRA. It's amazing. Okay, tons of information here. All right. So the next thing that I would probably want to do here is open that pull request. So a pull request, it's going to happen in the remote repository. I'm asking somebody responsible for the remote repository to make my code part of the main code, pull my branch back into the main branch. So opening a pull request, we do that on GitHub. All right. This is the main difference. People like Vitor said, GitHub, it's the same thing to everybody, but it's really not. Git is a source repository. GitHub socializes the use of the source repository, and it socializes coding. I like to say GitHub is Git on Facebook. That's really what it is. And this handles and acts just like that. All of us know how to go out on social media and communicate with each other. This is social media for developers. So I'm opening a pull request as this developer right here, a guy named Michelle, okay? So Michelle made the change, and what he's doing is he's asking Mark, I want you to review this. You're responsible for the pull. You're supposed to be updating this repository. Take a look at what I did and tell me if it's good. And if it is, approve it and pull it for me. So there it is. You can see that review is required. I cannot merge it, okay? Can't be merged yet. Not until it's accepted. So here's the review now of that pull request. So Michelle was able to do that easily. Now I'm acting as Mark now at this point in time. So Mark is out there and he sees that a new pull request has come in. And again, these are just notifications like Facebook. Somebody poked you basically. So Mark just got poked with a pull request, and there's the pull request. It's all spelled out for him. Mark can literally drill down into this request and see the exact lines of code that were changed. Every character, every byte. Okay, and there it is right there. There's what was done. Now Mark can review this and he can look at it and he can say, Ray, or Michelle rather in this case, this is not how we code. We do not hard code lengths. I want you to use a field reference file, etc., etc. That's the proper way of doing these things. So he's basically going to reject this request to pull. Okay, so this is a review process that can happen. And again, you can see it here. I'm requesting changes. We're going to send that back to the developer. So this is GitHub in action now, okay? Notice that this is not a source repository. This is socialization of the code. It's looking at the source repository. It sees things. It knows every line of code that changes and so on. And here's Michelle seeing that, this is no good. I have to rework it. So what Michelle is now going to do is he's going to go back. He's going to make another series of changes on this. And when he's done with that, he can commit again, okay? So the changes don't get made out there. The changes always happen locally, and once the changes are done, a commit is performed. And that commit literally puts the stuff back up there on the server, okay? So Michelle will go through that process. Further changes get done. So here's Michelle making those further changes. And after he does it, you can see it here, okay? After he does it, same thing as before. It's unstaged. He stages it. He'll commit it. Once it's committed, he's pushing to the same branch again. So he's updating that branch out there. And then what he'll do is he'll notify the person responsible that they can go ahead and review it again, okay? So as that person starts to review it again, what they'll see is the second commit, the third commit, the fourth, however many it takes. They can see every bit of the code, everything that's happened in there, and then they can decide whether or not things are okay. Now in this case, we're going to say, yes, things are okay. He did exactly what we asked. He's using a field reference field at this point in time. So we're going to reply to him that things are good. We're going to accept that change. You can see that here. We're commenting it. We're saying perfect. We're going to approve it. Okay. And then what we're going to do is perform the merge. Okay. So the merge is where we take that branch and we bring it back to the mainline code. So we're making this part of the main repository. Now, at this point in time, that branch can either go away or it can stay out there. It's totally up to you, how you're going to work. The schools of thought on both, I guess. But here's the merge. It's pretty easy. If there's no conflicts, it will go ahead and it will do the merge. If there are conflicts, it will display them. What's a conflict? More than one person change that code at the same time. Now, the conflict can be done at the developer workstation. I wouldn't expect the conflict to be happening up here. By this point in time, the developer would have already pulled other people's changes, used those, incorporated those, and so on. So what you just saw was GitHub socializing the development. You saw Git as the source repository, okay? And you saw some of the ARCAD plugins inside of RDI. So I was able to make my change in there, and you saw again that all I changed was a physical file. Now what we're going to do is we're going to kick off a build from Jenkins, all right? And again, we've got plugins that are installed in Jenkins, so we kick off the build, and what you would expect out of this thing, if you're not using ARCAD, and this process right here, okay, this is ARCAD at work. There's our build happening. Notice where it's happening, okay? It's happening on the IBM I in the background, and that's doing all the dependency analysis. Now, without that, you wouldn't see any of this. All you'd see is the file. That's it. You wouldn't have all the related programs. You wouldn't have the logicals associated with it. You wouldn't have everything else that the IBM I needs to function properly with this change. None of that would have happened. So that's Builder rounding out that change and showing you the change. You can see it all here. You can see the exact same thing. We're just showing you that because, you know, you've seen it in JIRA. Now you're seeing it in Jenkins. It's common information. Again, this is the XML file that got passed, and there's the thing that changed, the one thing, okay? And ARCAD took that and was able to round it out and give you the whole IBM I side of the change, all right? So all we did with Jenkins in this case was we triggered the build. Now, the build can be triggered from many different places, all right? Another place that we can trigger the build is a thing called ARCAD Builder. This is a client seat, okay? So you're not using Jenkins? Fine, you don't have to, right? You don't have to use RDI. You don't have to use any of these tools. There's a whole bunch of different ways to get to Git, to get to that repository, to get to GitHub. But however, if you're not going to plug in ARCAD and so on, you're not going to get a full change when you do this. You're going to have to do a lot of it manually. So that's really where we come in. So there's Builder, and again, Builder can go ahead and it can trigger the build for you as well. Builder will have the exact same information in it that you're seeing everywhere else. You'll see everything that was changed, all the different components. You'll see how well they did and so on. And really, the end result of a build, okay, is what's called an ARCAD version. If you're familiar with ARCAD, you know a version is a container for a change. And what that container is all the components that need to be deployed, regardless of the platform. And again, everything I just showed you works across platforms. So when you're doing that cross-reference analysis, you say, where does this physical get used? It will show you your PHP, your Java, that type of thing. So the end result of a build is a complete version ready to deploy with all the changes in it that you've asked for, all the components from Builder and so on. So there it is, the physical, the logical, all the programs and everything. And now all we have to do is give this thing a right click, and we can start to transfer it to the next environment. We can hand it off to drops. We can start to push this thing up the line. So that's really how a change kind of works. Go ahead, Floyd.
I was going to say, at this time, I want to hand things over to Vitor, because he's going to take a deeper dive into some functionality inside GitHub above and beyond what we showed.
Exactly. Hold on, and I will go ahead and I will do that. Here you go, Vitor.
And Vitor, we got about 12 minutes till our time is up, so I hate to rush you, but you said 10 minutes. I'm going to give you 10. You must be on mute.
Can you see my screen?
Yes, we see it. You're good.
Yeah, good size. Okay. So there's a ton of things that I could show, for example, like the global search and just the ability of really seeing what other people are coding, which language are they coding, what are they coding, what's work in progress, and that's that magic you can explore by yourselves in GitHub.com, for example, just by having an account. But one thing I wanted to show really is the power of the conversation that we just saw. What's the impact on this longer term, and what's something that GitHub can give me that I do not have today? For example, I come to this repository, and any of you can follow what I'm doing here, which is Atom. Atom is the organization, Atom is the name of the repository, and this is our open source text editor, which you can see here on the side as the green icon. So every time I do this, I pick a file at random. I swear, I'd never choose the same file, because it's so easy to replicate this that I challenge you to do the same thing as I do now or later. But imagine that I was just onboarded to Atom, right? Imagine you're a developer of a given language, and you just sat on your seat. It's your first day. You do the onboarding, you do all the technicals, all the paperwork, you have your accounts, and now, as the first task, someone says, there is a production issue. We have the stack trace, and we know where it blows up. Can you fix it? And obviously, it's my job. I'm going to say, yes, I can fix it. But you can imagine the anxiety, right? I know JavaScript or the given language that you can put yourself into, but there's the whole context of the project. Why was this developed like this, right? Just because something is written in COBOL is written in Java, it could be in 10 million different ways, the reasons why it is what it is. So let's imagine that I do have the stack trace, and I go here to, let's say, source, and you can do the same thing on any project. Doesn't need to be this one. And let's imagine that, for example, this one here, gutter.js. I don't even know what it does. I'm just making a point that I'm doing this just out of the blue. So I'm going to click gutter.js, okay? And I see all the code in GitHub. You can see the syntax highlighting. You can see the whole history of the file. You can even edit the file in line if you want. But let's imagine that I know which line this explodes because I have the stack trace. So what I can do is I click the blame function, and this will show me exactly when was the last time someone changed a portion of the file. So I can see that someone has removed I imagine CoffeeScript from this script because it shows that all the file was touched at the same time. So see, this is a proof that this was not a well-chosen file, because this file was changed as a whole in a piece of refactoring. So let me change a file which has a lot of changes. So for example, something that's been changed recently, the notification manager. Let's go to the notification manager. Okay, and let's click the blame view again. So this JSON is very active. So as you see here, you see more lines now. You can see that this was part of removing CoffeeScript as well, so that was probably a big pull request. But we get down here and we can see that there was other changes. There was some lines here which have added some further changes. So I'm just going to click here, imagining that this is the line that's blowing up, and I'm going to click the commit, the last commit that touched this code. Okay. And obviously, when you click here, and this is just adding documentation, for example, you don't have a big idea of what has changed, really, because the commit is something you could probably in SVN, instead of taking 2 minutes like I did to find this, you would have to analyze history, analyze who changed it, analyze the line changes, etc. The real power of GitHub is from any commit, you can jump to the pull request. So you can see here, this was pull request 15678. So there has been probably around 16,000 pull request conversations on this repository. You click the master and you go to the pull request. And this gives you all the reasons for all the code change that came from that single line analysis that we did. So you'll see that there was a conversation, which is remove coffee script from notification manager. There was a series of tasks here, and this implied a total of 6 or 7 commits. So although you started by looking at a stack trace, and that stack trace took you to a line, and that line took you to the pull request where all these changes were introduced. So you can see how that line changed as part of a much bigger change. And you could never do this with a normal version control system, because your unit is the commit, and the commit only gives you a sample. Let's click again. You click here, and you have a portion of what happened, but you don't have the whole story. The whole story is part of the pull request, and in this case, this one didn't contain a big conversation, but in some pull requests, if you test that with another file, you'll see the conversation, the code review, and someone like me telling Jason, hey, Jason, I think that will break in production in about a month's time. And I say, don't worry, trust me. And you come back in a month's time, and you see that, in fact, broke in production. Compare that with analyzing code just by reading the code. Right? I usually say that I've worked in the entitlement systems of the largest cross-asset platform in the market, if I don't believe anyone did a bigger one so far. But I worked on the entitlement systems in 2010. I know for a fact that those entitlement systems are still in production to see which views you have access to, etc. If you join that particular bank I work for, and you go to the global search and search for user MonteD, which was my username, and you go see, you can find all my pull requests and all my conversations. So you could see why I decided to use cache for entitlements versus not cache for entitlements. Who had arguments to do it like that, and who had arguments saying that that was a bad idea. That was 7 years ago, and all that documentation is part, like Ray was saying, of a social thread, because no one feels like this is writing documentation. You're just saying what you're doing with the code, which for a developer is supernatural. But you move this 10 years in the future, and the value of that is just incredible. That's it for me, Ray.
Okay. Thanks. Let me come back to the PowerPoint here and bring that back up. Hang on. If I can finish to do that. And I guess what we're going to do is, with the remaining time here, try and take a couple of questions. Hold on, Floyd. I'm trying to get there.
Yep, no worries. We got 5 minutes. Obviously, if you do have questions and we don't have enough time, you're more than welcome to follow up with us. Vitor and Ray and I and the rest of my team are available to answer any questions or talk about any sort of integration. And I've seen some of the questions. Just kind of get back to the slide deck real quick while you're thinking of questions, because if you have any, I'd like you to submit them now. But in the deck, we will also make this available, as I mentioned, upon request, and I saw somebody did already request it. Here are some additional resources that are available for your review to make you green screen guys happy. I think you did notice we did show you one green work active job screen in there, but we didn't show you any SEU in our little example. You can go to the next slide.
What's interesting, though, and we should mention, Floyd, is the fact that all that stuff that Vitor just showed about the blame and so on, that works with native code as well as open code. So
that is correct.
Yeah.
That is correct. We just showed you a simple example there.
Yeah.
I guess the thing we wanted to say, this is not all tools. Don't think it's a magic wand. You know, adopting this methodology is important. This culture you can't really ignore is important. All of that is important in conjunction with these modern tools. As I mentioned, I can't emphasize how much that we can't ignore the existing culture that we have. That's one of the common mistakes that gets made and will result in delays and slowdowns and failures and bottlenecks all through this process. There's several other pitfalls to ensure success. My plan is to have another series down the road where we talk about maybe common mistakes and the kind of the step journey to DevOps, but that's for another time. And in there, we'll talk about things that are both upstream and downstream. Downstream would be things like compliance, and upstream would be things like getting the business involved across the entire pipeline value flow. So the last slide I have, and hopefully you're thinking of your questions, is just kind of a quick summary. Again, I think the key here is if you want to talk, you got a risk-free migration path to open source here. Feel free to give us a call. We also do have automated migration kits from some of the traditional IBM tools that will help you get to this point much quicker. And with that, I'm going to kind of open the floor, and I'll pull in some questions, and we'll finish up. Again, if you have anything you'd like to follow up with us, just please contact us. So one of the questions was somebody wasn't using Rally, but another system, and the reality is we see that a lot. They weren't using JIRA; they were using Rally, actually, in this case. And so there are connectors. The link between JIRA in this case was between GitHub and JIRA, but there are plenty of those connectors out there, APIs that are available for us to integrate whatever kind of tool stack might be common wherever your knowledge base lies within your company. So I don't think that would be necessarily a problem. As Ray mentioned, Jenkins is or is not part of your story. That's fine too. You could always manually launch the builds. But the goal of DevOps is try to automate as much as possible. But with automation, sometimes there becomes these latency periods in between for approvals. And so we try to look at the whole value stream as a whole when we start to talk about DevOps. Somebody wanted to know if we work with SQL tables. Do we create tables or alter tables? And the truth is we do both. And we could get a little bit technical, but for the most part, we try the one way first, and we could see if we could get away with an alt table. And if we do, we'll do that. And if not, we do that in QTemp kind of quietly in the background. And Michelle can talk, our CTO can talk more about that, or Ray can probably talk more about that on the way we handle those around SQL tables. So the answer is yes, we can work with them, and we can manage whether that's a create or an alter. Let's see what else that we've got here. Let's see. I don't know if Michelle wants to jump in. Maybe he's got an interesting question. Michelle, you can unmute yourself too if you like, since you've been doing the bulk of the answering here.
Yeah, he has been answering most of the questions as they came in. That's why you're not seeing a lot to answer at the moment, Floyd.
Yeah, if he's got anyone. On my IBM I have RPG sources and members of source files. Have I to change that to use Git? And the answer that Michelle gave was no. The solution will allow you to stay into source files, but the only way to compile also CLE, CLPs, DDS, etc. So what we're saying is we do take the build process kind of back to the I think, in that particular example. It's a little kind of a deep dive there. If we have a lot of these tools already existing, how do we determine what else we need? And that's a good question. And the reason why we chose these tools was the very thing you just stated, is that you have a lot of them. And that traction is what kind of drove us to use JIRA and GitHub and Jenkins in this particular instance. But again, that's probably a conversation that we should sidebar and take on the side, dealing specifically with the strategy and the knowledge base that you have in place in your particular company. Anything else, Ray, that you see?
No, there's a ton of great questions, Floyd, but we're hitting our time limit here, and we should respect their time. We can answer these via email, and we will get in touch with you folks via email, and this recording will be available after as well. So,
yeah, I'll take one last question.
Okay.
The ARCAD package include also some tools for automatically testing the code. Is it possible to trigger the automatic testing of the code and just promote? And the answer is yes. You can automate that. You could still put in the safety nets of peer review in there, or if you will, approvals. But the goal is to try to improves those latency periods, because sometimes to make the code change only takes a couple days, and then to actually test it might only take a couple days. But the handoff between testing could take a couple weeks to provision the correct environment, for instance, or the database to test again. So those are the areas where you start to look at, when you start to look at the whole value stream. Those are the kind of discussions that we would have with you.
Yeah, and what Floyd is talking about there is ARCAD Verifier, and the real strength of Verifier is knowing by component what tests it needs to run. So that's all part of our repository and the cross-reference checking that we do. It's built right into the testing as well.
All right, with that, I apologize for going over. As I mentioned, we have a lot of information, and we would be glad to answer any and all questions. We're going to go through this. We'll leave this panel up for a few minutes, but I'd like to thank everybody. I'd like to thank Vitor for attending from GitHub today. Great content, great expertise in the area. I'd like to thank Ray, as always, my partner in crime, doing the heavy lifting here. So with that, please forward all your questions or reach out to us. You have some contact information there, and we really thank you for participating in today's webinar.
Thanks, everyone.
Thank you.